Alright guys, finally in this video we're going to talk about the third strategy to find equivalent fractions, and that's strategy number 3, and that is to use multiplication. Okay, so the first couple we're going to see some visual models. So up here we see that 3/5 is equal to 6/10. We can see that because they're on the exact same spot in that visual model. So number 1 wants us to divide the model below to show that this 1/2 is equal to 5/10. So if my denominator is 10, that means I need 10 equal parts. So that means I want 5 parts here and 5 parts here. So that means I would draw 4 lines. 1, 2, 3, 4. So that would give me 1, 2, 3, 4, 5 parts here and 5 parts here. So that's a total of 10, and now there are 5 that are shaded with a total of 10. Number 2, draw a model to show 1/6. So I'm going to draw a bar, and I want a total of 6 parts. So I'm going to divide it in half, which means I want 3 on this side and 3 on this side. That gives me a total of 6. Then divide the model into twice as many parts to find an equivalent fraction. So twice as many means times 2. So that means each one part is going to become 2. So now, if I count up my total pieces, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And before, I should have shaded in 1/6. And so now, that would equal 2/12. So that would be an equivalent fraction. So 1/6 equals 2/12. So number 3 shows us this, we're going to take that 1/6 and we're going to multiply the numerator and the denominator by 2. So 1 times 2 is 2, 6 times 2 is 12. And what you should notice is that we get the same thing. So either way, if you draw that model or you use that multiplication, you should get the same thing. So the question says, why does it make sense that the fractions you wrote in problems 2 and 3 is the same? Because this is just 2 different ways to find equivalent fractions. It makes sense to double both the numerator and denominator. It makes sense that we would double both the numerator and the denominator there. Okay, if you would go to that second page, looks like this now. Starting with number 5, we're going to fill in the missing numbers to find 2 equivalent fractions to 4/5. So we're starting with 4/5 on both of these, and we're going to find some equivalent fractions. So I know that 5 times 2 equals 10. If I multiply by 2 on the bottom, I have to multiply by 2 on the top. 4 times 2 equals 8. 8/10. Next one, 5 times 20 equals 100. So if I do 20 on the bottom, I have to multiply by 20 on the top. 4 times 20, cancel out that 0. 4 times 2 is 8. Add that 0 back on. 80 out of 100. So number 6, look at problem 5. Explain how this 8/10 that we got right here is equal to this 80/100. Well, when you look at it using that multiplication strategy, I can see that 8 times 10 equals 80, and 10 times 10 equals 100. So since I multiply by the same number, that means they're equivalent. Since I am able to multiply both the numerator and denominator by 10, that makes them equivalent. Okay, so number 7, shade the model below to show 1/5. So that means one of these is going to be shaded. And then it says, then show 10 equal parts and write an equivalent fraction. So that means that 5, that 10 equal parts, would be my denominator, or the total amount. So that means 10. So I know that 5 times 2 equals 10. So 1 times 2 equals 2. So if I were to show this, I would need to divide each of these in half. And now I've got 2 parts shaded out of 10 total. Okay, let's look down here. Shade the model for 2/3. So 2 of these will be shaded. And this time, show 12 equal parts and write an equivalent fraction. So that means 12 is going to become my denominator. So 2/3 equals how many 12ths here? Well, I know that 3 times 4 equals 12. So if I multiply by 4 on the bottom, I have to multiply by 4 on the top. 2 times 4 equals 8. So my equivalent fraction should be 8/12. So since I did 3 times 4, that means each of these need to be broken up into 4 parts. And so now I've got a total of 12 pieces, and 8 of them are shaded, which is equal to 2